Good afternoon, one and all. I welcome all of you to the lecture Advanced Software Engineering and Technology. In today's lecture, we are going to discuss about reviewing system design. In previous lecture, we have identified boundary conditions. Is this presentation visible to you? Is it visible? And am I audible?
No, no, sir.
Uh, okay, just a minute. Okay, now is it visible?
No, sir. आता दिसते सर स्क्रीन.
Okay. In previous lecture, we have discussed about the boundary conditions identification, and in today's lecture, we are going to discuss about the reviewing system design. Uh, like analysis, system design is a evolutionary and iterative activity. Continuously, we have to evolve. Suppose in today we design a system and there is opportunity to do something new design. In next time we have to design something a novel technology like that. Suppose we have designed a computer design like this, okay, but here is suppose something uh, not proper design. So at next time we will be design very good design. We have to evolve, evolutionary and iterative activity. This is continuous activity means iterative activity. Unlike analysis, there is no external agent such as the client to review the successive iteration and ensure better quality. There is no any external entity to show the design, how design will be, but we have to do ourselves a very good design by modifying again and again, by modifying the old design again into the new design. This is the iterative design. This quality improvement activity is still necessary, and project manager and developer need to organize review process to substitute for it. Like suppose a manager and developer need to organize the project according to the novel technology. With error free design we have to produce for the purpose of the client or the users. Several alternatives exist, such as using the developers who were not involved in the system design to act as an independent reviewer. There are several alternatives. Developer were not involved in the design, like a reviewer, or to use developer from another project to act as a peer review. These review process work only if the reviewer have an incentive to discover and report problem. Suppose you are the developer of the project in a particular company. As a developer you are getting the salary, so without getting any incentive, extra money to review that project, you will not do that. So that we have to give some intensive to the developer to review the design, then he will be review that design and modify it. So we have to give them incentive to discover the new design. In addition to meeting the design goals that were identified during system design, we need to ensure that the system design model is correct, complete, consistent, realistic, and readable. We have to think in meeting uh, to the design goal. We need to ensure what we need to ensure. We need to ensure the design model. It should be correct, it should be complete, it should be consistent, realistic, and reliable. The system design model is correct if the analysis model can be mapped to the system design model. Suppose we have designed a system like this. Okay. According to our analysis, before this design we have made some analysis. According to analysis, this system design should be made. This system design should be made according to our analysis. Then we can say this is the complete system. You should ask the following question to determine if the system design is correct. We need to ask some questions to correct identification into the system. Can every subsystem be traced back to use case or non-functional requirement? This question we want to ask to correct the system design. Can every subsystem be traced back to use case or non-functional requirement? Suppose there is a system and there are some subsystem. Have we traced that all subsystem, their non-functional requirement and use cases, are they satisfying? Suppose we want to design a use case actor for withdraw money. Is that included in that subsystem or not? That we have to trace. Can every use case be mapped to a set of subsystems? Suppose there are use cases we have created, withdraw money, deposit money, like this. Then we have to map all these: withdraw money, deposit money, and some transaction made by the banker or officer. And this is user can withdraw the money from ATM machine. This is suppose ATM machine. So can every user can be mapped to set of the subsystem, every use case. These are the use cases that we have to trace. Can every design goal be traced back to a non-functional requirement? There we need to provide the help in the software. That is the non-functional requirement, but that is needed to use that particular system. So can every design goal be traced back? Every design goal be traced back to non-functional requirement? That's such type of questions we need to ask to correct the design. It is every non-functional requirement address in the system design model. Is every non-functional requirement address in the system design model? Is there? We want to ask the questions, because non-functional requirement is also important, so it should be addressed into the every design model, so we can able to use that design. We will know how this model will be used, how this model will be used, how this model will be used, if and only if there is the help given, non-functional requirements if given there. So in review the design, system design, we want to ask like these questions: does each actor have an access policy? Suppose there are several actors in one system. Is there policy to access each model of that system? Is there policy made by developers or the company owners, is implemented in our software? Is every access policy consistent with non-functional security requirement? Like this question we need to ask to review the system design. The model is complete if every requirement and every system design issue has been addressed. Our model will be complete, our design model will be complete if every requirement and every system design issues has been addressed properly. You should ask the following questions to determine the system design is complete. When we can say the system design is complete, do all the subsystem have definition? Suppose there are several subsystems in one system, but all should be defined. Why this subsystem is there, why this subsystem is there, why this subsystem is there in the software design. Have the boundary conditions been handled? Is there boundary condition in between two subsystem? Why this subsystem is different from this subsystem? Their accurate boundary conditions should be there. Like camera and the printer is another device, camera is another device, but both are the devices required to operate the systems. But there to identify these two terms are different, we need one boundary. Camera is always different, printer is always different. Similar kind of boundary conditions we have to handle. Was there a walkthrough of the use case to identify missing functionality in the system design? Again, we want to go through the all use cases to identify missing function. Is there any function which we miss? Because of that, our software will be fail. So we have to review the system design and identify the missing functionality, missing use cases. Have all use cases been examined and assign a control object? We have to examine all the use cases and take of that and find the controls of all that use cases. That is become then complete design of the software. Have all aspect of system design, that is hardware allocation, persistent storage, access control, legacy code, boundary condition been addressed? All we have to find: hardware allocation, persistent storage, access control, legacy code, boundary conditions. All we have to address properly, then that model design will be proper complete design of the system. The model is consistent if it does not contain any contradiction. The model should not get any contradiction, means opposite direction. Suppose we want printout and we have their camera instead of printer, then that is directly contradict. For printing we need printer, for taking the input as a photograph, as a video, we need a camera. So our model will be consistent. If you should ask the following questions to determine if a system design is consistent. For identification of consistency, we need to ask these questions. Are collection of object exchanged among the subsystem in a consistent manner? All the collected informations we have to exchange in the whole subsystems. Suppose we need print of this, we need print of this, we need print of this, then all these should be connected to the printer so that we will be print that. So that should be consistent in manner. Existing collected, all the collections of object among the subsystems are conflicting, design goal prioritize. We have to find the confliction. Is there any confliction mixing design goals of one subsystem and another subsystem? Does any design goal violate a non-functional requirement? Suppose there is non-functional requirement because of a particular subsystem, that will be violated. We have to also find that. And are there multiple subsystem or classes with the same name? We have to also find out. There are suppose three subsystems, three use cases. Are these same name or different? That should be different. We have to identify that, then that will be consistent. If we make similar names subsystem 1 and subsystem 2, both subsystems name is similar, then which subsystem should be act first and which will be act second time, that their system model will be conflict. So to consistency, we need to give the name exactly different subsystems into the software design review. We want to find that in reviewing subsystems system design. The model is realistic if the corresponding system can be implemented. You can ask the following questions to determine if subsystem system design is realistic. For a realistic, have concurrent issue, example, contentions, deadlock has been addressed. Are any new technology or component included in the system? For realistic, we want to find the test of technology and component. Was appropriateness or robustness of this technology or component evolved? If it is evolved, then how it is revolved? We have to ask like these questions. Have performance and reliability requirements have been reviewed in the context of subsystem decompositions? There, suppose we use the subsystem decomposition. Is there really need of system decompositions? Are these subsystem are useful in the all this model? Is there any extra component added, new technology is there? Was appropriateness or robustness of this technology component evolved? Like this, we have to find the performance as well in the subsystem reviewing the system design. The model is reliable if the developer not involved in the system design can understand the model. You should ask the following questions to ensure that the system design is readable. Are subsystem name understandable? Subsystem, suppose there is one system and in this system there are suppose some subsystem. Now you see at this diagram, there is no name given to this diagram, means name is not visible. So how it will be understandable? So it should be understandable. So we want to ask the questions to there. Do entity example subsystem classes with similar names denote similar concept? Do entities with similar name denote similar concept? Then that will be conflict. So readability should be there. There we will not readable that system. Same names subsystems are repeated there, then our project will not be readable that subsystems. As well as suppose the name is not understandable, what is written in this, what is written in this, what is written in this, there is not visible names, so this is the ununderstandable, you will not understand this. Are all entities described at the same level of details? We want to ask like these questions to reviewing the system design. In many projects, you will find that system design and implementation overlap quite a bit. For example, you may built prototype of selected subsystem before architecture is stable. In many projects, what happen? We have to find the system design and implementation, that is quite overlap. In the prototype design, we know, suppose we are going to design this system and this system is similar at this level. In order to evolve, in order to evaluate a new technology, these these lead to many partial review instead of encompassing review following by the client sign off as well as for the analysis. Although this process yields greater flexibility, it also requires developers to track open issue more carefully. In system reviewing, many difficult issues tends to be resolved late, not because they are difficult, but because they fail through the cracks of the process. We have to find like this component also, those component are not useful in the system design, that we have to remove from the system design by at the time of system designing. Now, managing system design. How to manage the system design? In this section, we discuss the issue related to the managing of system design activities. In analysis, the primary challenge is managing the system design is not maintain consistency while using the many resources as possible. In the end, software architecture and the system interface should describe single cohesive system understandable by the single user person. We first describe a document template that can be used to document the result of the system. Section 7.5 is given. We describe the role of assignment in the next sections and all. So, documenting subsystem. System design is documented in the system design document, means SDD. SDD is important document. There we have the documented the role of system design, how system will be. It describes design goals set by the project, subsystem decomposition with UML class diagram. In the document DSS, what is in DSS? In DSS there are UML class diagrams, hardware software mapping with UML deployment diagram, data management access control, control flow mechanism, and boundary conditions all are described with the UML diagram. The SDD is used to define the interface between the teams and developer and serve as a reference when architecture level decision need to be revisited. We will put together this document DSS. DSS is the SDD is the design system design document. System design document. We will keep this side by side and take the reference as a by explaining the team. As a developer, we suppose telling to our team member about the system architecture, system design, we have to keep this document beside and take the reference from that. This document consists of some UML diagram. The audience for the SDD include the project management. Who are the member of SDD? System design document. Who are the member? The audience are project management. The system architect, that is the developer who participated in the system design, and the developer who design and implement each subsystem, all are the member of SDD. SDD, system design document. Document system design. The first section of the SDD is an introduction. in first section of the document SDD, we have to write there introduction of the project, and its purpose is to be provided a brief overview of the software architecture and the design goal. It also provides reference to other documents and traceability information. Example, related requirement analysis document, reference to existing system, constant impacting the software architecture, all that should be provided in this document. Means related requirement analysis document, reference to existing system, is it should be written in this document SSD. Means suppose we are going to design the new software in a particular company, but designing before that new software we have to analyze the previous existing work, how their work happen, is there any software or not. If they were not using any software, then how their work was happening there, that should be studied and that should be written in this SSD, in this system design document SSD. The second section, current software architecture, describe the architecture of the system being replaced. If there is no previous system, this section can be replaced by the survey of current architecture for similar system. The purpose of this section is to take the explicit background information that system architect use, their assumptions and common issues the new system will address. Document system design, the third section, proposed system architecture. Proposed system architecture should be there in the document. The document system design model of the new system, it is divided into the 7 sections. Overview, present a brief view of the software architecture and briefly describe the assignment of the functionality to each subsystem. Documenting system design. System design document, how this is first in SSD. This is the SSD. In first SSD there is introduction. In introduction, purpose of the system, design goal, definitions, acronyms and abbreviations if used there, then references and overview. In second section, current software architecture, how their current software is, the purpose of software architecture, overview, subsystem decomposition, hardware software mapping, persistent data management, access control and security, global software control, boundary conditions, subsystem services and glossary. All these should needed in the system design document DSS. This is figure 7.18 example outline of the system design document. Suppose you want to take the project for the last semester, then you have to follow this guideline, this system design document. According to this, you have to design software, all the softwares. This is the primary stage of the software design. You have to follow all these points, all these guideline to system design. Subsystem decomposition, describe the decomposition into subsystem and the responsibility of each. This is the main product of system design. If you have any question regarding system design, please ask.
No, sir, no question.
So when you will be write any project, you will be complete any project, you have to write first SSD, system design document. In that system design document there are 4 points. In first point, introduction, there are 5 points. First purpose of system, why we are going to design the system, why we are going to design the software, the purpose of that software is should be written. Then design goals, there are how much objectives, how much goal we will be finish, means first level how we will be do, in second level how we will do it, do in third level how, and what we will be do, that should be written in the design goal. Then definition of all subsystem, why this subsystem is needed, why this subsystem is needed, why printer is needed, why camera is needed, why their display is needed, all that should be right into this ESSD, document system design. Then references we have to take from the current system. Then overview, how system work overall, we have to write there. If we use there like this word SSD, means abbreviation SSD, then we have to write there system design document, like this word UML if suppose use there, then unified modeling language. So we have to write the abbreviations if we use that abbreviation into our project. Their explanation we have to write there. Current software architecture, how their current software is there, we have to also find. So you have to follow this guideline into the documenting system design. In today's lecture we find documenting system design and reviewing system design. For reviewing the system design, we have to ask different type of questions to fulfill the review process. We have to review, we have to study. Once we have designed a system, then we have to review that, is there that subsystem is needed or not, all their work we have to review. We have to review system design. And in previous lecture we discuss about the identifying boundary conditions. Do you have any question regarding reviewing system design? You can ask. Jyoti,
No, sir, no question.
Shital, if there is no question, then we'll stop here.
Okay, sir.
Okay, thank you. Have a nice day. You can join another lecture.
Okay, sir.
Bye.